Hi everyone, my name is Rituja and welcome to Data to Crunch. So today we are kicking off an exciting new playlist which is dedicated to two most powerful tools in the world of data engineering and analytics, and those are Apache Spark and the Databricks. So whether you are a beginner or an experienced data professional, understanding Spark and Databricks is a game changer now. So these technologies form a backbone of how now these modern businesses process, analyze, and derive the insights from the massive data sets. So today we will try to cover the topics which are getting displayed on the screen, where we will try to learn more about the predecessor of Apache Spark, which is nothing but MapReduce, then how this Apache Spark was evolved from the MapReduce, and lastly we will try to cover why we started using Databricks. So let's start by looking at the MapReduce, which is the predecessor of Apache Spark. So we can say that MapReduce is a programming model of processing some large data sets in a distributed way. So it is a basically part of Hadoop ecosystem, and it works by dividing its tasks into two main steps, which is nothing but map and then the reduce. So this model was designed to handle big data efficiently, particularly in a distributed environment. So let's start by understanding this concept with a basic example that will help you visualize how this functions. So let's say suppose you have one input file with this content, hello world, hello, and the map reduce. So the first step is map, where the text data gets divided into smaller chunks, that is nothing but the words, and each word gets paired with the number 1 to represent its occurrence. So here it got divided into hello 1, world 1, hello 1, and then the map reduce 1. So the next step is shuffle and sort step, where the words that are same that gets grouped together, and we can say that this step gets handled by the system. So we have hello two times, so it shuffled that hello world for 1 comma 1, and then the world is for one time, and then the map reduce for the one time. And then the last step is reduce step, where for each word the count gets added together to get the final word count. So we got hello word count as 2, word 1, and then the map reduce 1. So overall we can say that MapReduce was revolutionary because it allowed companies to process petabytes of data across a distributed clusters of machines. But as the big data needed to grow, MapReduce started showing some of its limitations. Now we will try to look at those limitations. So the first limitation was disk I/O overhead, because MapReduce is built on the concept of writing intermediate data to the disk after each phase, which is nothing but map and then the reduce. So it introduced a significant disk I/O overhead, and here is why this is a problem, because it has started showing slower processing. So after map phase, the data needs to be returned to the disk before being shuffled and then read back during the reduce phase. So this constant reading from and then the writing to the disk can slow down the processing speed, especially with the large datasets. Then the next one is disk bottleneck. Since this disk IO is slower than in-memory operations, the process can become a bottleneck, significantly hindering the overall speed of the job. And the next one, we can say that inefficient for iterative algorithms, because many machine learning algorithms and the certain data analysis tasks require iterative computations, where like data needs to be read, processed, and written back multiple times. So in MapReduce, this means that data is repeatedly read and written to the disk, which is much slower than operating directly into memory. So the next one, or the next limitation we can say, is no advanced analytics, because this MapReduce was primarily designed for batch processing and it does not naturally support more advanced forms of analytics, which are nothing but real streaming or the machine learning. So we can say that this MapReduce is batch processing focused. So this MapReduce is great for the tasks that can be processed in maybe discrete or isolated chunks, like for example aggregating logs or performing some ETL task or transforming data for reporting. But we can say that however, like it does not have built-in support for real-time processing or the streaming. That is nothing but like processing a continuous stream of data, maybe from the sensors, logs, or the social media feeds. So we can say that afterwards it also lacks the native ML support, because for machine learning tasks you need to build some custom workflows or use some external tools also. The MapReduce programming model was not designed with the machine learning in mind. So while you could technically implement some of its algorithm using MapReduce, it is inefficient compared to some modern approaches right now. Then the next limitation we can say is complexity. So MapReduce programming model, it can be quite difficult to work with due to its complexity and lack of high level abstraction. So we can say that it has verbose and low level capacity, because MapReduce, it requires you to define map and the reduce functionalities explicitly, and these functions are generally written in low level programming languages like Java, we can say. So this leads to some verbose, complex and error prone code. And the next one, we can say that it is also difficult to optimize, because MapReduce jobs are typically harder to optimize. You have to manually tune various aspects of the job, like number of reducers or maybe partitioning schemes or the number of mappers. So we can say the complex process, especially as data sets grow larger and more complex day by day. And it also lacks the flexibility, because MapReduce is relatively rigid programming model, and it does not lend itself well to the complex transformations or the iterative workflows which are common in the tasks like machine learning or the graph processing. So because of these limitations, here comes the Apache Spark. So Apache Spark was created to overcome the limitations of MapReduce while keeping the principle of distributed computing intact. So basically we can say that it is an open source distributed computing engine designed for the big data processing. Now let's see why Spark was developed. So the first one is speed. So unlike MapReduce, which writes its intermediate data to the disk between these tasks, Spark keeps all this intermediate data into RAM. So this results in significantly faster data processing, particularly for iterative operations like those are found in machine learning, graph analysis, and data analysis tasks. So these iterative tasks require multiple passes over the same data, and in Spark, all this data is kept in memory by allowing it to be processed more efficiently. So this concept is called in-memory computation. So the next one is unified engine. So Spark was designed to be one-stop solutions for these diverse workloads. So while this MapReduce was primarily limited to batch processing, Spark was engineered to handle both both batch and real-time streaming workloads simultaneously. And for that, it has started using Spark streaming for the real time. Then it also supports machine learning via MLlib, then the graph processing via GraphX, and the SQL querying using Spark SQL. So overall, we can say that this unified approach means that users can perform a variety of data processing tasks. Example, real-time analytics, machine learning, graph processing, and the traditional batch processing into a single platform without having to resort to the multiple tools. The next one we can say is a simpler API use. So MapReduce required users to write their codes into low level code, write this low level code into Java. Spark offers high level APIs in multiple languages like Python, Scala, Java, and R. So these APIs are more expressive and concise, which enables the user to perform complex tasks with the less code. So the simplicity of Spark APIs allowed for the faster development of batch processing tasks, and it made easier for the data scientists and engineers to write, debug, and test their code in this rapid environment. So we can say while this Apache Spark was revolutionized for this data processing, it still had some challenges for the users, especially in terms of setup, scalability, and the collaboration. That's where this Databricks comes in. So what is Databricks exactly? So Databricks is a cloud-based platform designed to simplify the use of Apache Spark while enhancing the collaboration and the scalability. Now we will see why this Databricks was created in depth. So the first one is simplification of Spark. So this Spark, though it is a powerful tool, it can be difficult to configure and scale, particularly in large clusters. So setting up a Spark cluster requires a lot of technical how and know concepts, which includes deciding on cluster size, configuring sources, and managing nodes. So Databricks abstracts much of this complexity, offering fully managed cloud platform where these Spark clusters are automatically set up and scaled up as needed. So users don't have to worry about configuring these Spark clusters manually or dealing with this underlying infrastructure. So the next one is collaborative environment. So this one of the standout feature of Databricks is the interactive notebooks, which are Databricks notebooks, which allows data scientists, engineers, and the analysts to work together on the same project in a collaborative manner. So these notebooks are similar to Jupyter notebooks, which are built on the Spark. So users can write, run, and visualize their Spark jobs directly within the notebook, and the platform keeps the track of all the changes, version controls, which fosters a team-oriented approach to these big data projects. So we can say teams can collaborate in real time on the same dataset, making it easier to experiment, iterate, and share the results quickly. So the next one is optimized for cloud. So Databricks is optimized for the deployment in the cloud environment like AWS, Azure, and the Google Cloud. So it provides seamless integration with these platforms and offers enhanced scalability, reliability, and easy cloud services approach. So Databricks on AWS and Azure offers out-of-the-box Spark clusters with this auto-scaling, load balancing, and integrated monitoring, and integration with these other cloud services. For example, Azure services like Azure Data Lake, Azure Blob Storage, and the Azure SQL database. It provides a complete end-to-end data workflow starting from the storage to the processing. So, all right, we have covered some functional concepts today where we explored the history and evolution from MapReduce to Spark. We have learned how Spark's in-memory processing and distributed architecture make it faster and more efficient than its predecessors. And also, we touched on Databricks briefly, which is the platform that takes Spark to the next level with its collaborative environment and powerful tools. So in the next lecture, we will look on these points which are getting displayed on the screen. So if you are excited to deep dive and into these topics and master this Apache Spark and the Databricks, this playlist is for you. And in the upcoming videos, we will break down each aspect into more detail, and we will try to cover these advanced features like Spark streaming and machine learning also. But before you go, don't forget to like, subscribe, and hit a bell icon so that you don't miss any content. And in the next video, we will try to cover more topics with this Databricks. So thanks for watching, and until next time, keep crunching that data.